Alright, so far we found that VCD is minus 9 volts. We used that information to find the loop current for loop B and loop A, which is the final currents for, so the loop B current will be the final current for R3 and R4, and therefore we can find the final voltage for those resistors. The loop A current is going to be R1, R2, R5, and R6 final current. So therefore we can find the final voltages for those. So let's go ahead and I'll carry this information over to the next screen and clean this stuff up a little bit. And then we're going to use that information to do some current analysis to solve this thing. Alright, so let's go ahead and I'm going to write my VCD is known to be minus 9 volts. Okay, and the current for, so IA equals IR1 equals IR2 equals IR5 equals IR6. Okay, so that IA current was found to be, let's look at it real quick. Oh boy. IA is 23.97. 23.97 milliamps. Okay, now IB was found, and that's going to be the current of R3, and that's also going to be the current of R4. IB, and let's take a look at that, 26.92 milliamps. 26.92 milliamps. Alright. Okay, so now that we have our currents, and I'm going to go ahead and just draw in some polarities. And so we said minus to plus 9 volts. Alright, and that's plus, minus, plus, minus, plus, minus, plus. Whoops, let's put that on the outside here. You'll see why in a second. So plus, minus, plus, minus, plus, minus. Alright. Okay, so I know a little bit about the flow of current in these guys. So the current will flow in electron flow. It will be in this direction through each of those components. Alright, so there will be some current flow that way, and current will flow that way. Current will flow that way, that way. Alright, so into this positive, out from that negative. Alright, and there will be no current through C1 as we've assumed it's a full charge. We don't yet know the voltage there. Now, that diode, I can tell the direction of its current. It's got to be going in from negative to the positive side. Alright, so now let's look at these nodes. I got that node at C and that node at D. Alright, so that tells me, okay, so this is our IA current on that side. This is our IB current on that side. And I still need to find my I from C to D. IC to D. So from negative to positive, C to D is going to be negative current. So flowing from this side being more negative than this side. it will flow from negative to positive. So that current number we'll just say that it's negative just based on the direction we're looking at. All right, so now with some node analysis now, I see that I've got R5 coming in and I've got ICD coming in, or the diode's current coming in, and then some current leaving. So only one branch or one path is leaving the node. So if that's true, then IB must be larger, because the sum of those two, ICD and IA, should combine to be that IB. Now I think I've written that down wrong. Let me go verify. It is larger. Let's go look and see. I think I did write that down wrong. Well, no, that looks right. That does look right. Let's see. My calculator had a bit of a problem a moment ago, so I'm not able to show that anymore for now. But I did write that down right, so let's go look at what we've got here. Alright, so let's just analyze this node. I'll work in blue here. So this node right here, I've got IA and ICD going in, and that's going to equal whatever IB is. Alright, so let's write some numbers in here. So 23.97 milliamps. Okay. And minus or plus ICD equals 26.92 milliamps. Alright, well that's all super duper awesome. What I really need is ICD, so let's say ICD equals, well in this case 26.92 milliamps minus 23.97 milliamps. Alright, ICD equals, now I can't show you my calculator, but I will go ahead and do that right now. 26.92 milliamps minus 23.97 milliamps gives me ICD of 2.956 milliamps. Alright, and that all being the case, I can look at this other node and I can see that I've got two things leaving, and I've got R3 or IR3 or IB again entering, which is going to give me the same equation. I've got IB entering equals IA plus ICD. Okay. Alright, now this number, just absolute value, comes out, and we're going to use the direction of current flow and the voltage present to determine the polarity for our final answer, as if we were to put our meter in there. So red lead on C and black lead right on the anode of that diode. We should see a negative number coming in on our meter. Alright, so let's go ahead and solve those. Now that we know that current ICD, let's go ahead and solve those voltages so that we can solve for the A to B voltage, and we'll be done with this circuit.